So good morning, good afternoon, and good day to all of you, and thank you for coming along to another one of our webinars. This webinar is about shore power, onshore power supplies, it's sometimes referred to, and that's what it's going to focus on. Why are we doing this webinar? Because there's regulations coming into force in the very near future, and because there's a lot of interest and we've been asked a lot of questions by our members and by the industry as a whole. So we thought we would bring this webinar, and Jordan has compiled a lot of these slides, and also we've spoken to a lot of these panelists who have a lot of expertise in this area. So we've compiled this webinar for that. What I'm going to do first of all is I'm going to talk about the background, the backdrop. Then I'm going to hand over to Jordan to do a little bit more of a technical description, and then we're going to hand over to all the panelists. So we really want to invite interaction in this webinar, and we ask you to put questions into the chat or the Q&A, and then we will try and answer them throughout the course of the webinar. If by any chance we not able to answer all the questions, we will try to put them into a follow-up pack after the webinar. And what the plan is within a week of the webinar taking place, we plan on sending a follow-up pack to everybody who is registered for the webinar. So that's within 1 week for those of you who couldn't attend, or those of you, who are on holiday or whatever. So that's the plan, to get it to you within a week. And then it will go live on YouTube at a later stage as well. So without further ado, I'm going to get started, and we're going to start talking about the technical details, the regulations, and the overview involved with shore power, onshore power supply. So really, I want to turn the clocks back to October. I was sitting there in the Albert Embankment when the adjournment was made to the IMO NZF, the Net Zero Fund. That took place in October. And, as we all know, the can was effectively kicked down the road. There was a proposal to adjourn. There was 57 votes in favour, 49 against, and 21 abstaining. So really, the IMO NZF does not take place in its present form. So the real teeth driving the regulation at the moment is the Fuel EU Maritime. And that's partially why we're going to focus on this throughout this webinar a little bit, because the Fuel EU Maritime and the AFIR, which is the Alternative Fuels Infrastructure Regulation, I'm probably going to repeat that because I'm a big believer in repeating some of these terms so that you become more familiar with them. So before I go on to a little bit more on that, I think it's very important to introduce the panel. We've got a group of experts here who've got a lot of relevant experience in this area, and I do believe the best way of doing this is by handing over to each member of the panel and allowing them to introduce themselves. So I'm going to ask the panel to introduce themselves in the order that it's shown on the screen, and then after that it'll come back to me, and then we'll start the webinar in entirety. Thank you very much, and over to you, Jordan.
Thanks very much, Mark. Great introduction there to shore power and why we've got this webinar going on today. My name is Jordan.Hatch. I've been part of the loss prevention team here at NorthStandard since 2024. And before that, I spent 13 years at sea as a seagoing engineer on a variety of vessel types. Within my role in the loss prevention team, I've also been involved in the navigating decarbonisation team at NorthStandard, who bring these webinars such as the ones today to discuss the various topics that are causing, that are leading to the maritime industry to decarbonise. Thanks, Sarah.
Thanks, Jordan. Good day, everyone. My name's Sarah McCann. I've been at the club for coming up to 14 years now, and I'm a senior solicitor in the External Affairs Department at NorthStandard. Alongside Mark and Jordan, I'm also part of the club's decarbonisation expertise team. And I'll hand over to Chris.
Morning, everyone. Thank you for the invite to this webinar. So I'm Chris.Poyner. I'm head of shore power at ABB with global responsibility for our shore power activities. So for people who don't know, ABB are a large global engineering company with a focus on electrification and automation for sustainability. And we're quite well known in the marine sector for products such as the Azibod, but also in this instance, we do a lot of shore power activities on the ship and both on the land. On the land side, we've our experience comes from doing about 70 projects historically over the last 20 years. And so thank you very much for the invite, and I look forward to this webinar. I'll hand over to Maria.
Thank you, Chris.
Thank you, Chris. Yes, thank you so much for the invitation, and good morning and good afternoon to everyone. My name is Maria Boss. I'm the CEO of Plug. We are a Norway-based company, both developing, owning and operating shore power infrastructure for the maritime sector. We work across the full value chain, from project development and investment to construction, ownership and long-term operation. And we have around 8 years of operational experience with onshore power supply, and have been investing around 60 million euros in this type of infrastructure. So I'm very much looking forward to the webinar, and hopefully can contribute to some more insight into this really important topic. And I'll hand it over to you, Peter.
Thank you, Maria.
Hi, everybody. So my name is Peter Selway. I work for a Danish company called PowerCon. We just specialise in shore power. We've installed systems all over the world. Over 200 berths around the world have got technology installed. We install, commission, manufacture all kinds of shore power systems, including the world's largest shore power system in Miami and Europe's largest shore power system in Copenhagen, and all kinds of shore power systems for all vessel types. Thank you.
Thank you very much, Peter. Excellent introduction from on the panelists there. And I must say, it's quite refreshing to have so much cooperation between, Chris, Maria and Peter in these webinars. It's good to see everybody working together, with ourselves, with other technical bodies and the industry as a whole. That's the only way we're going to make decarbonisation work, by cooperating together and by learning from everybody else across the industry. So I'm going to quickly touch on onshore power supply. In shipping the onshore power supply is driven in shipping, in my opinion, by a mix of regulation, economics, environmental pressure and port competitions, port competitiveness, which is a hard word to say, trust me. But anyway, FuelEU Maritime incentivizes shore power at berth. That's a very important point. And we just spoke before there how the teeth of the FuelEU really are biting in now, because that's the only thing which has been fully decided. The IMO NZF the can has been kicked down the road, as we've just discovered. So FuelEU Maritime, it will stay in its present form, and it will not be superseded by IMO in the short term. Who's to say? We don't know what's going to happen in the future, but at the moment FuelEU will be the regulation that's driving a lot over the next couple of years. Separate to that, and all part of the Fit for 55 package, is the AFIR, which is the Alternative Fuels Infrastructure Regulation, and that requires EU ports to provide power for container ships and passenger ships by the 1st of January 2030. Now, correct me if I'm wrong, but 2030 is really just around the corner. We've just started 2026. It's not that far away. So, Jordan, can you just take over at this point and give us a talk through of, shore power, how it works, how it's going to work, what the regulations and timelines are, and how all that is going to influence and impact our members and ship owners across the globe. Thank you very much, Jordan, and over to you.
Yeah, great. Thanks, Mark. And it's important to remember as well that although FuelEU seems to be at the forefront of a lot of the media, there's already been a lot of global regulations in place globally across other regions to incentivise shore power. And it's not a new technology either. That's something else to keep in mind, and our panel will discuss that later in further detail. But if we start at the beginning of what actually is shore power, and we can compare it to what we see around locally at our homes, with a lot of people now charging plug-in points at their homes for cars, as well as in local areas. So a vessel can then come alongside and essentially plug into their own power supply. That power supply coming from the national grid, much like the power supply you are all using right now at your local setups or office setups. Now, how does that actually look in reality behind the scenes? Well, it's a bit more complicated depending on how we look at it. So first, the port here needs to actually get that power delivered from the national grid. And that's one of the biggest obstacles that the port can actually have in terms of do they have the infrastructure and cabling required to carry the amount of power that's required to the amount of ships that can come to a vessel and the varying power loads that they may require, as well as the variety of different ships that will arrive to the ship itself. And that power itself will come from the national grid. And again, that will vary depending on region on how that is sourced. So some national grids will still be relying on fossil fuels, while some, of course, will come from renewable sources. If we look at the EU, for example, 50% of all electrical energy produced is from renewable energy sources. But compare somewhere to somewhere like Norway, they have approximately over 80% of their electricity produced from renewables, utilising hydropower resources. That power is then delivered to the port, and this is where offshore power specialists today install things in the ports that allow each ship to get the power that they require. So each ship that comes to a vessel, comes to a port, will have different power requirements, as we've already touched on there, and that will vary depending on their power demand, depending on how much power they need whilst alongside at the berth, and it'll also vary on depending on their voltage and frequency that they require. Now, ships coming to ports, again, depending on their design and type, will range anywhere from 440 volts all the way up to 11,000 volts, and that frequency is going to vary between 50 or 60 hertz. And this is where we need these shore power converters here to meet the ship-specific demands for that vessel. Once that's met to the vessel, we then need a way of getting that power to the ship, and that's where we need a flexible cable management system here. And it needs to be quite a flexible one and suitable for all vessel types, because if you imagine one vessel comes to port, it has a plug-in location at the bow. Another vessel comes to port, it has a plug-in location at the aft. So then we need to have a cable management system there that can reach all points. We also need to consider that one vessel arriving could be a completely different shape and size to the next vessel arriving. And one of the biggest questions we got asked prior to this webinar, and often a big question asked around shore power itself, is will the plug actually connect to that ship? Will it be compatible with the next vessel that visits too? And there is international standards around there to ensure compatibility there, and that is something that the panelists will touch on later in our discussions too. As well as the different plug-in points on a vessel, we also need to consider that a vessel does move relative to a quayside, so therefore it needs to be dynamic, the cable, in order to not become too tight or get in the way of cargo operations or cause a tripping hazard or anything like that, as well as not become too loose if the vessel is moving relative to the quayside there, depending on cargo operations or shifting tides. So what are actually the benefits of connecting to onshore power supply? Why should we do it? Well, first of all, the emissions are significantly reduced. And here we're not talking about just CO2, we're talking about nitrous oxides, sulfur oxides, and particulate matter, all of which we know are affecting the atmosphere and human health. So there's decarbonisation benefits and a human health benefit here. Secondly, another type of pollution here is the noise and vibrations. So that's going to make it better for local communities nearby, less noise and vibrations coming from the ships that are staying alongside. And that's also better for onboard practices too, for the ship crew that are on board the vessel. And one which is sometimes overlooked is the maintenance benefit we actually get from connecting onshore power supply. So first of all, if you shut down your engines whilst you're alongside and you no longer got that operational pressure of having to produce that power on board, that can create an next maintenance window to get the maintenance done and required on the engine on board. And additional to that, any planned maintenance on engines are often based on running hours. So if you use onshore power supply whilst alongside, you have a benefit there of actually increasing your planned maintenance intervals, therefore reducing the amount of maintenance over a full calendar year. And then, of course, as touched on already, the crew comfort will be enhanced, less volume on board, better sleep and rest for the crew on board. And then for the engine room team specifically, usually there's a big engine running in the background there. It's very hard to communicate and work in an engine room. It can allow for better communication there, a bit of peace and quiet for the engineers, as well as increased fault finding potentially, where things that can often go unnoticed, such as bearing noises or small air leaks. With that engine shut down now, you might have potential there to detect these small faults before they become anything bigger. And then there is a financial potential too. And this, of course, depends on the vessel type, where it's trading, and the applicable greenhouse gas penalties that might be to where they are visiting in ports. That's because if they are connected onshore power supplies, we'll touch on in a moment, greenhouse gas penalties can be reduced quite a lot. And then returning to that maintenance point there, where your maintenance intervals across a full year may be reduced, that could lead to a financial gain here, reducing the total maintenance costs across a full year. But aside from that, as Mark touched on already, it is the regulations which are driving a lot of adoption and investment in shore power. So if we start with the EU, and that's what Mark was touching on already at the beginning here, the Alternative Fuel Infrastructure Regulation requires all EU ports, and that's the Trans-European Network transport ports. There's a list of them available within the Fuel EU regulations. They require enough shore power capacity for all container and passenger ships of over 5,000 gross tonnage to have shore power installed for them by the end of December 2029. Fuel EU Maritime is then tying directly into that, and that is therefore requiring the same ships, container and passenger ships to connect to that onshore power supply where it's available, or use alternative zero emission technologies when they're at that berth for over 2 hours. And there's actually an additional benefit to onshore power supply when we consider Fuel EU Maritime. So if you've attended some of our webinars before, you would have heard Mark introduce Fuel EU, where it essentially considers fuel over a full life cycle analysis. So that's the well to wake of that fuel. So that's meaning how that fuel is produced all the way to the point that it's burned through the funnel. So if we apply that to shore power, we would have to assume that you would have to consider exactly where that power is coming from the national grid in order to regulate how much emissions it's made. But within the Fuel EU Maritime clause, there is a specific one there within the regulation, there's a specific one there that specifies that if you use onshore power supply whilst in these ports, you can count the emissions as zero. That therefore has the potential of reducing any increasing any surplus or reducing your deficit amount in terms of your greenhouse gas penalties. EU emissions trading scheme is also another emissions there, depending on how much emissions you have to surrender. And again, using onshore power supply here will actually reduce the amount of emissions you are required to surrender. Now looking globally, in China, since 2019, China has required all vessels capable of doing so to connect to shore power since 2019, and that is for vessels staying at ports for over 3 hours, or sorry, over 2 hours, but it becomes 3 hours if staying in the coastal ports. But that specifically excludes tankers for safety reasons, which we'll also touch on later. But since 2021, they've expected all cruise ships that visit China to actually connect to that onshore power supply. And then across the Pacific, we have California. And this is the forefront runner in shore power supply, where they were almost one of the first ones to require connecting to onshore power supply. And that is through their California at berth regulations, the California Air Resources Board at berth regulations. And since 2014, container ships, passenger ships, and reefer ships have been required to connect to onshore power supply or use alternative methods. They then expanded this regulation and scope of the regulation in 2025 to include that with tankers, and this is the first time we've seen tankers included, and that has caused a big press in the maritime industry, especially from classification societies, and ensuring that safety requirements are met, because here when we're talking about tankers, we need to consider the safety impact there, where any onshore power supply connection needs to be intrinsically safe, avoiding any detrimental hazards with the types of cargo that they carry. And in 2025, the regulation came into place for only ports of Long Beach and Los Angeles, but from 2027, that is expected to expand to include all ports in California. And then in the UK, very similar to the EU ETS, the UK ETS emissions trading scheme will come into force in the 1st of July this year. And here at berth emissions are also considered, in which case we need to then connecting onshore power supply can reduce the amount of emissions to surrender. And the UK has also seen a lot of investment in installing shore power too at various ports. And then if we look at the global scale of this, as Mark touched on the IMO net zero framework here, that onshore power supply, if that does come into force, will support the emissions here and reduce any penalties as well. And if we even look at the short-term measure, the carbon intensity indicator of vessels, CII, connecting to shore power is going to reduce your emissions overall, and therefore potentially reduce your CII rating for specific vessels as well. Now, before we hand over and get started on our panel discussions and the various questions that you've kindly submitted already in the registration of this, we'll just have a quick look at the ship differences and how they've been affected here. So this kind of highlights here at the different power demands that different vessels have. So you can see passenger ships there with a high power demand, right at 12 megawatts there, with bulk carriers typically having less power demand. And that depends on the ship in itself. Imagine a large cruise ship coming alongside. It has a massive floating city, a lot of power demand there, and that is why they've been at the forefront of the emission regulations. As well as that, passenger ships have a very predictable route. That's made it easier to predict and have compatible shore power. Knowing exactly where they're going to be and at which berths makes it easier to plan for. And then container ships closely following there with a lot of power as well. That's due to the power consumption they have for all the refrigerated cargo that they carry. And then tankers as well. They've been coming on the scene recently, as discussed there in California, where class notations have been developed specifically for tank onshore power supply, taking into consideration the hazardous zones that they require for connection. With that, I'll now hand you back over to Mark so we can get started on our questions and get our panel involved a bit more. Thank you very much.
Okay, thank you very much, Jordan. Very interesting there. When I was actually looking at that, it actually something I'd never thought of before crossed my mind. For those of you that have sailed on ships before, particularly engineers, when the engine stops when you're sailing along, sometimes you wake up in the middle of the night. And I thought to myself, when you're in port and you don't have an engine running, it's going to be quite unfamiliar for some engineers on board ships. But then I thought, well, of course, when you're in dry dock, it's exactly the same environment, really, isn't it? You're running on shore power when you're in dry dock, so I suppose it's not too dissimilar. And us mariners would have to adapt to that situation. But excellent. That's really an interesting start now. So what we're going to do is we're going to go into the panel discussion. But just before we do that, I just really want to pitch a question to you, Jordan, which came across my mind as you're going through the slides there. And then perhaps, if you want, you can pass it on to the rest of the panel to see what their thoughts are. But I noticed you in your operations slide there, and I can bring that slide up on the screen now. You were talking about various ports around the world, and I'm just wondering, have you had a chance to look into and research how these regulations differ across the world, and could you elaborate on that?
Yeah, so the ones we've sort of picked out here on the slide, these are the ones where penalties can be applied if ships do not connect to the onshore power supply, depending on the specific regulation that is applied. But what we will see, or we already are starting to see, is where, for example, if we look at Europe, that's for all of them European ports. There's some European ports that are slightly pushing ahead of that, or trying to get, as you said, their competitiveness, really trying to be ahead of the other European ports. So I know, for example, with the port of Hamburg, although they don't need shore power for all cruise vessels until 2029, they've pushed ahead and had a target there set of 2027, where they're going ahead of that as well. There was also a circular release from a maritime circular release from India just last year, and that outlines onshore power supply requirements there, with no fines set out yet or detailed regulation or anything, but they have set a target there that they expect all vessels, and they don't actually name any vessel types, that'll be all vessels, to connect to their onshore power supply by 2035. So that's a target they've set to. So it is increasing globally everywhere. Within that as well, within that Maritime India circular for shore power, they specifically mention the IEC 8005 standards for plugs, connectors, etc. So I don't know if the panel want to expand a bit more on that and what that actually means and how that ensures global consistency and compatibility with the different plugs and connectors.
Okay, thank you. Excellent, Jordan. I've just stopped sharing the presentation so we can head over to the panel now. I think it's a good question you posed to the panel there, Jordan, and I think perhaps if the panelists speaking from our external presenters would like to give their thoughts on it, or if they don't, that's fine, it's completely up to yourselves. But I'm just going to start in no particular order, but I can see Peter's first on my screen here, so I'll start with Peter, then Maria's next, and then Chris is after that. So if you just want to give your thoughts, if you don't, that's fine, but we would like to hear from what you've got to say on that. Thank you.
No problem at all. Yeah, no, absolutely. So it's a really important question, and probably the most frequently asked question we get is about standards. And if you take nothing away from today's call, it's the fact that shore power really isn't new. The 8005 standard was created in 2012, has been implemented all across the world. and has been implemented very, very successfully. Navies of the world have been plugging in to shore power for decades. So although a lot of the regulations that Jordan's been talking about are really pushing the adoption, the real wide-scale adoption of shore power now, this really isn't new. The technology is proven, it's been tested for decades now, and works extremely well.
Okay, thank you very much, Peter. Interesting. Maria, do you have any views on this or comments, please?
Yeah, no, I perfectly agree with what Peter's saying. Obviously, there's still some way to go with regards to the standardization for all vessels, but we have lots of answers and lots of solutions that's working today and is able to reduce emissions or actually take away the emissions while the vessels are at berth. So for us as a developer, it's all about speed these days. We just need to make sure that we can build more of it. So yeah, I think that's my take on it.
I think that is going to be a challenge. As we said, 2030 isn't very far away, and with these things, a lot of it's left a little bit too late in the day in my experience in the shipping world. So yeah, I think that's a good point. Thank you. Chris, over to you. Do you have anything to say on that?
I mean, just to add to that comment, the standard is very good. And for shore power, it's not possible to have a one size fits all for all vessel types. Every vessel type has a different power requirement, different location. So the standard dictates by vessel type, whether it's cruise, whether it's ferry, whether it's bulk carrier. It dictates what to expect when you go into a port, which means you can have a standardized plug. So, like I said, the standard covers a lot of stuff, which and answers a lot of questions. I think that's my input.
Thank you very much. I mean, one other question I just want to, and this is for anybody whoever wants to answer this, just to any panelist at all, please. Existing international standards for ops and plugs. Is there anything you'd like to, sort of elaborate on when it comes to that? I know we've discussed it briefly there, but is there anything else you'd like to bring to the forefront here to the audience watching this at the moment?
If you're not sure what your power requirement, the IEC standard tells you the worst case for the vessel type. A big question we'll have is so as a supplier for the shore power industry, whenever someone's interested in shore power on a port side, generally, because the ships generally get converted because they need to, whereas on the port it's more of a business decision. Then the main 2 points are: have we got the power available? What's the business case? And the first question, I mean, business case is there's lots of ways to look into that, but power availability, first you've got to know what your demand is. And the problem with shore power historically is in the early phases, people don't know what the vessels consume. And for some operators, the vessel consumption is a closely guarded secret in some of the cruise businesses because it's seen as a disadvantage if they use more power, less green. So it's difficult to get the real values, but as a port, they're then expected to provide a system that can do everything. So, but what the standard does is it dictates by the cable management type what the maximum power you can deliver that type of vessel is, and then you can work back and reduce it based on your understanding of the vessel that will be connecting.
Right, okay, excellent. Thank you, thanks. If the audience haven't got any other questions, I'm going to press on with some other questions here, and I'm going to put a few of you under the spotlight here, but there you go. Shore power availability. Will ports be ready? Could I just ask for the external speakers to give sort of 10 or 20 seconds thoughts on that, please? Will ports be ready, in general? What's your thoughts on that? Just a 10 or 20 second overview would be really appreciated because you're getting to see it really at the forefront.
I would propose this is a question for Maria, if that's okay, Maria, because you're doing more of the energy as a service. I think for myself and Peter, we're suppliers, so we'll supply as much as anyone wants. But I think Maria, you see more of the operational side, so this might be a good one for you if that's okay.
Yeah, perfectly happy to answer this. I think well, some ports are already ready. Some ports are definitely doing the right things and are working to be ready. Some ports are in big trouble. That's my sort of short take on this. And as mentioned in the presentation, in the introduction here as well, there are some, there could be some great challenges with regards to having enough grid capacity on the quay side when needed. And that's not something that is typically solved within a couple of years. Although the technology is available and there might even be funding and money ready, they might still be up for a big challenge in order to be ready for 2030. That being said, I think that many ports are also overcomplicating things and also probably believing that it is a challenge more than knowing that it's actually a challenge. And also to comment on some of the things that you said, Chris, with regards to the consumption. I think that the consumption is very often overestimated, so that the port thinks that they need more power than they actually do, which is also could be a reason why they're not moving forward with a project, because they think it's not doable. So, but yeah, the short answer is that it's a big difference, and I do believe that we will see ports that will not be ready, unfortunately. And it will be interesting to see the consequences of that.
Thank you. And I'll have to be honest, Maria, that doesn't surprise me that you said. So you're going to say something there, Peter? Were you? Sorry.
Yeah, I was just going to say that, yeah, I completely agree with Maria. I think what a lot of the challenges are, there's so many things out there. What about future fuels? What's, things like ammonia and hydrogen, how are they going to affect these kind of systems? So a lot of ports have been sort of thinking, well, let's see what happens and maybe make a decision later rather than sooner. But it's clear the regulations are really pushing for shore power. And one of the key points, again, we'd like to address in this presentation is the fact that even if you look at future fuels, most of the future fuels, things like hydrogen and ammonia, are produced using electricity. So it's always going to be more efficient to use electricity straight onto the vessel rather than use electricity to produce a future fuel like hydrogen, for example, ship it to where it's required, put it into, and then using that fuel then to generate electricity for the vessel. So it's always going to be more efficient to use shore power straight from the grid rather than these future fuels. So obviously we believe this is why we're in this business, but shore power's got a strong future. And if you talk to operators like Maersk, they've got a really well-developed plan of how all their future fuels are going to look at in the future. And in every circumstances, they're planning on using shore power. So it gives you some kind of indication that really it is going to happen.
Exactly, and just to add to that, exactly as Peter said, the cheapest way to provide electricity is use electricity, not convert it to another medium in between. But there are certain business cases where that works. If you've got excess energy, you can generate green hydrogen. But I mean, the efficiency lost in the conversion is quite high. But in reality, if it's wasted energy anyway, if we're having to pay a wind generator to turn off because there's excess energy, why not create something you can use at a later date? But like I said, it all comes back to power availability, and there's lots of ways you can do it, and a lot of this can drive into the business case for these projects. But going back to whether I personally believe the ports will be ready, I think there's a lot of interest, there's a lot of activity in the market, and exactly like Maria says, certain ports won't be ready. A lot of the ports are switched on and going to be ready. The important message from the supply chain on this sort of thing is it's not too late to reach the 2030 target. I think there's a number of people just putting on the too hard pile and thinking we're never going to make it. But you've got to bear in mind that if for a port to put shore power in, it's probably from the point at which they order the equipment, it's delivered and commissioned, maybe say 18 months. But before that stage, they've got to do all the planning. They've got to work out where all the cables and all that sort of stuff can physically go. Generally, ports have got all kinds of nastiness under the surface. So it's a longer process, but it's not too late for 2030, but don't be leaving it to 2029 to start the process, because that is probably not going to happen. That's my advice. But I think that the industry is very focused, the solutions are there, and if you can work on the business case and check you've got the power availability, there's no reason that the ports can't implement this. And with future fuels, the cost of electricity is going to be more and more attractive for shore power than it is at the moment when you're looking at alternative fuels on the vessel or alternative fuels for generation.
Thank you. And just a little bit of reflection on what the panelists have said there. I mean, you can never start too early is almost what we always say with all of these regulations. As soon as you find out that something's over the horizon, then start looking into it, because we do see that with a lot of our members and ship owners across the board, that those that strive first to make the biggest changes are often in a better position later on. I suppose another point I just want to bring to the attention there, and I think it's a very good point that you raised, that to provide electricity, use electricity, I suppose the limiting factor is battery capacity. It would be ideal, obviously, we're looking specifically at shore power here, but obviously, for some of the smaller vessels and ferries and hybrid vessels where they rely solely on electrical power, you could obviously charge them up completely in port and let them go. Obviously, we're not quite there with some of the bigger vessels, and whilst battery technology may be used for peak shaving and operations of auxiliary equipment, we're not quite there with the battery technology being used. But I do think it's a very good point that you brought there, that that the electricity being used is useful. So do you have something to say to that, Chris? Sorry.
I was just going to say, Mark, there's a number of projects for shore power that are already integrating energy storage and using it well. We delivered a project in the Port of Toulon where they've got solar, they've got battery, they've got the shore power system, but this is the south of France. This isn't North Wales where I live, so the weather's a bit better for the solar. But they've got the battery, and the purpose of that is to reduce the maximum capacity from the grid, because they pay for the connection. So if they can reduce the peaks, it saves their cost. So it's not all about a lack of power, it's about smoothing out the power and having an overall cost. And if you're going to, if a port needs a 10 megawatt grid connection or 10 MVA, then if they're paying for that, they need to utilize it all the time. And this is where battery energy storage comes in, where you can use the excess to charge the battery, and then you never exceed the 10, but you make the most of it. What you don't want to do is pay for a large grid supply that you don't use and underutilize. Yeah. But the other thing that's often forgotten in ports is we talk about shore power, but you've got straddle carriers, you've got cranes, you've got all kinds of other electrical equipment that's also a consumer. And it often gets missed when you're looking at the shore power, the requirements of shore power. But the more we electrify, the more things need power. So, it's an interesting, but it's all doable. And the project I mentioned in Toulon also has a hydrogen fuel cell that they can feed the power from as well. But I think anything with hydrogen is more of a sort of a proof of concept at the moment rather than a mainstream solution. But all the solutions exist, and electricity is agnostic. You can create it using multiple sources, and you can consume it using to do multiple things. And I think that's the important thing, and that's why, as Peter said, shore power is here to stay, because it's central to all this in the marine environment.
Excellent. Very interesting.
Mark, if I may just comment on that with regards to the fully electric vessels, I just want to comment that I think that's a big trend that we've seen a couple of years now, that we've been getting more and more inquiries from vessel owners that are looking into fully electric, really big vessels like bulk carriers. We have an ongoing project with 2 fully electric PSVs that will operate in the northern part of Norway. So I think also going forward, we will see definitely OPS driven by regulation, but we'll also see more and more projects also requiring a charging infrastructure from shore, so DC powered charging infrastructure. So it's going to be more diverse infrastructure on the quay side going forward in order to accommodate all the needs, either if it's things that needs charging on the quay side, or if it's vessels. So I fully agree also with what Chris says around that.
And fundamentally, it's the same technology. It's whether you're charging vessels or providing shore power. It's fundamentally the same technology. So if you're installing shore power, depending on the design of the vessel, if it's an electric vessel, fundamentally you can use that to charge the vessel as well.
And the key to all this is power management as well. If you've got multiple charging systems and multiple vessels, then you've got to make sure you manage the peaks of your vessels. But there's also technologies that exist. One of the things that ABB do nowadays is weather routing. And the theory with that is that you can route around storms for safety, but you can also route for the optimum fuel consumption. Now, for a traditional vessel, that makes no difference. But if you then make that a hybrid or an electric vessel, if you can do the routing to reduce the consumption, then when you come into port, you need to charge less, which means your peak of power is less. And I think that's what we're seeing with marine. Rather than look at all the items in isolation, if you look at them as a system, there's a lot of good technologies there to really decarbonize across shipping, and it's about utilizing the majority of them. And And in my experience, the more you consider and the more you apply, the better your business case for the whole scheme. It sounds crazy, but it's worth spending that little bit more to give you much more back. And that's the way we kind of see it. But I know it's not as easy for the vessel operators of the ports, but there's a lot of solutions out there to really, make this more attractive to the operators.
I think some important points that have been raised there is that very much we're looking at the whole supply chain here. It's not just the supply chain, it's the power supply chain. We need a holistic overview here and not to look at shore power in isolation. So I think, some very valid points brought to the table there. The next question really, sorry, Chris.
Just going to add one point on it, Mark, as well. And it doesn't just stop at the shore power as well. What we're finding is where we're doing a big shore power system at Portsmouth, but then the ferry operator or the cruise operators are now saying, well, the vessel comes in, we turn the engines off, we're on shore power. So, but these guys going on these trips, these guys, we want that to be zero emission now. So it's adding more. It's interesting how it rolls out. It once it reach one milestone, it leads to more. And I think it's very positive for the environment, but for the ports, it's created more of a headache because then they've got to do destination charging on a bus network. But it's exciting times. But you've got to do it in steps, should we say? You can't really do it in one go. But it's good to see the motivation from the industry.
It's not without its challenges, I think, most certainly, yeah. But that's with any form of decarbonisation. We always put the slide up on the screen to show the challenges versus decarbonisation. We all know they're there. There's no easy flick a switch answer to all of this. So, very interesting points. Thank you. The next point I just really want to focus on is, how is a ship operator, owner, or charterer, or whoever you are with an interest in operating your ships, how can you look at which ports have availability? Now, I know Jordan and I have looked into this before, so I'm going to allow Jordan to further his research on this and share it with the audience on the potential options available. But then after Jordan said his piece, then please feel free to chip in yourselves as well, Peter, Chris, and Maria, or Sarah, if you know anything else that you want to bring to the table on this. But I'll start off with you, Jordan. Thank you.
Yeah, thanks, Mark. I mean, first and foremost, the vessel, as they should anyway, regarding of their port call, should liaise with the port in advance, see what they actually have available. They know going to that port already, see what they have, see what capacity they have, depending on the berth availability and so forth. But in terms of getting an overall picture, just for your own understanding, there is people out there such as classification site DNV. Through their DNV Veracity platform, they have a live map sort of from their own research and what they deal with from as a classification society, have a map there of which ports are installing shore power supply. There's also various studies out there as well. For example, Transport and Environment have a study showing the uptake of shore power supply that was done just last year. I can share a link in the chat after this as well, showing sort of what the uptake is around the EU, which ports are required as per the regulation, and how far in advance they are actually getting them installed. There's also other resources, coming across one called the Liquid Grid, a similar live map. That's quite a nice interactive one there as well, because they've tried to take into consideration what the national grid actually is and how, whether it's coming from fossil fuel or renewable resources, which might come into play when we consider the IMO net zero framework for onshore power supply. I'm not sure if anybody else in the panel has any other resource that can be used in terms of evaluating or having if sort of an operator is looking to plan its route or where shore power is available.
They're the key point, the key ones that I know of, Jordan. But again, one thing that really surprises me is the lack of engagement between vessel owner operators and ports. We're only going to solve these problems that Chris mentioned and the challenges if we increase engagement. If ports know that vessel owner operators are looking at or want to use shore power, they will move forward, and vice versa. If they're looking at planning shore power installations, if they engage with vessel operators and owners, they know exactly what the demand's likely to be, and we can all make better plans together.
It's that holistic approach that we discussed before, isn't it? Really,
it really is. It's so important.
Yeah, excellent. Okay, well, Jordan.
I was going to say, sorry, that's typical of decarbonisation, though, isn't it? Everyone's trying to do it all in isolation, where we've all got the same problems. It's ultimately probably the same solutions. It's just the application, and like you said, collaboration, learn the lessons once, don't make the mistakes. I think that's the key across decarbonisation in general.
No, I fully agree. Jordan, if you could just share some of those links in the chat just when you get a chance, please, that'd be really appreciated. Sarah, I'm sorry, but I'm going to put you under the spot now, under the spotlight for a little bit. I'm going to ask you, what are some of the contractual implications and things to be aware of from a P&I club's perspective on the contractual side, effectively? Thanks.
Thanks, Mark. Yeah, and I think that really goes to the point you raised earlier about kind of that preparedness. And I think contractually, it's really important for the parties to be thinking about those contracts in place, and particularly for the owner-charter relationship, looking at those charter parties. Contractual certainty is going to be really important when it comes to use of onshore power. And your standard charter forms, such as NYPE, obviously they don't include kind of arrangements for use of shore power within them. So it's therefore going to be a need to kind of look at those charter parties, particularly those longer term charter parties, and think about what clauses will need to be included. So just in terms of kind of thinking about what will need to be looked at, particularly some examples will include obviously having clauses which specify when shore power must be used, any conditions in respect of that, and also any exclusions as well which might apply. Also the cost allocation side, who is going to be ultimately responsible for the costs associated with the use of onshore power. And also in terms of any time loss, what implications that might have. So under a time charter, is there going to be kind of any off-hire associated, or could there be exceptions to lay time or demurrage under a voyage charter? So having real clarity on that, so kind of to avoid kind of the risk of disputes arising. Also kind of looking at any force majeure terms and how they're drafted, and whether any interruptions due to, say, mandatory shore power breakdowns, whether that could fall within those terms. And as I say, obviously, just ensuring the kind of looking at those charter parties to ensure kind of minimizing the risk of disputes arising. And with that as well, looking at the documentation side and the kind of the recording within logbooks, the methods of verifying meter readings, and also the frequency of billing and tariff structures as well, and ensuring that anything within the charter party aligns with any user agreements as well with the shore side. Also in terms of maintenance as well, any maintenance obligations, ensuring clarity on that, and price volatility and cost adjustments as well, particularly again, as I say, for those longer charter parties, maybe having an adjustment clause within them to address any variability in shore power rates as well, and ultimate kind of liability as well. So I think there are a few examples of kind of particular clauses that would need to be kind of included, and this kind of should be being looked at when looking at those existing charter parties or new charter parties that will be entered into, where the use of shore power will be kind of being used.
Okay, excellent, thanks, Sarah. And I promise you this is not pre-rehearsed, but I'm going to put you on the spot here, Sarah, and say, have we received as many charter party inquiries as you expected we would have in relation to shore power at this point in time, or
So we've certainly, I know we've received some inquiries relating particularly to clauses in respect of CARB, for example. So kind of being able to assist members with, as I say, making sure that you've got robust clauses in there and clarity and the kind of the contract. I know there's been a few claims as well in respect of kind of the use of onshore power, and particularly loss of time elements, as I say, where there's been kind of interruption to cargo operations or compatibility issues as well. But as yet, not many, but I think going forward, that's something that with an increasing use of onshore power, you would anticipate that there may ultimately be more claims and inquiries kind of arising as time goes. But I think that then goes back to that point about preparedness, and if you've got clear contractual terms, then that should hopefully reduce that risk of seeing claims arising, because you've got that clarity within the charter parties and the kind of those agreements with the shore, as well as to responsibilities and where the obligations kind of will lie, and how any kind of cost is to be allocated.
Thank you very much, Sarah. If I could just bring the Q&A to the panelists' attention, I'm going to first of all start off with the first question here, and I'm sure we could answer this, but I think it's more for the panelists because your expertise to give your overview on it. So the first question is, how do ports ensure compatibility with both high voltage 6.6 to 11 kV and low voltage 440 volt systems and 50-60 hertz frequencies for vessels from 1000 TEU to 23,000 TEU calling at the same berth? And the question to follow on that is, are shoreside frequency converters looked at? Would anybody like to pick up on that, please?
I can answer how we've solved it in practice, at least in Bergen, and I'm sure Peter and Chris can say something also about the technological possibilities. But at least the way we've done it in Bergen is that we have separate systems for high voltage and low voltage on the same quaysides, and also separate cable management system in order to accommodate different types of vessels. I know that it's technically possible to have it in the same system, but there's also a loss, which is from an economical point of view, operating shore power not a very good idea if you have too much loss. So that's why we've opted for separate systems. But I'm sure this is something that is being developed. So maybe Chris and Peter have some input on that side.
Yeah, absolutely. I agree. All the systems we've got ever done, when there's a low voltage and a high voltage system, we've kept them separate. The PowerCon approach is to very much productize these systems. So you're almost buying like a EV charger. When you come to PowerCon, it's a standard off-the-shelf system. Within high voltage, our system can provide any high voltage required, and within a low voltage system, they can provide any low voltage between 380 and 690. But really, because the way the standards work, there's 80,005-1, which deals with high voltage, and -3 deals with low voltage. We really do keep them separate. It works out more efficient and less complex by doing it that way.
And I think just to add to that, for ABB, we do a whole portfolio of sizes. But again, I agree with Maria and Peter here. So for a small, what you've got to look at, a low voltage system is generally only up to 1 MVA. The high voltage systems are kind of 1 MVA up to 20 MVA. And you don't want to have a 20 MVA converter feeding 500 kilowatts to a little fishing vessel when it could be feeding a cruise ship, in simplistic terms. So you have to kind of look at what the use is, where the use is on the berth, and then design a system based to optimize that. But it mentioned about shoreside frequency converters. Generally, the majority of projects that we see have a 60 hertz vessel and a 50 hertz grid. Obviously, we operate in the US where it's 60-60, and you have some 50 hertz vessels. But generally, a frequency converter is considered for each of these projects. And the important thing is if you've got a 50 hertz and a 60 hertz vessel, and they're both coming into port at the same time, you want to be able to supply both of them. In which case, it makes sense to either have a separate system or have one from the grid, one for a frequency converter. For the project we're doing in Portsmouth, we've basically got a large converter generating all the 60 hertz and the 50 hertz from the grid, so you can at each berth use as much 50 or 60 as you like. But like I said, it's very much on a use case depending on the vessels. So you need to study what the vessels are coming in, what the requirements are, and optimize the system based on that. And exactly as Maria said, you don't want to have a big converter. It's not just about wasting the capacity, but you want to operate at the good efficiency range in this, because it all comes down to having grid availability. And if you're wasting the power by having a very inefficient system, it makes no sense.
Yeah.
Sorry. Abrupt ending to that comment.
Efficiencies of scale, yeah, I totally agree with that, and I can see where that's coming, and that's fine. That's great. Thank you very much. The next question, and I think we've covered on this partially, but is the ship shore connection standard same across the globe? Is there a regulation covering this point? We've touched on this roughly, but if anybody would like to elaborate on that. And then the second point to that question is about tankers, onshore power supply on tankers. Obviously, we're aware of the intrinsically safe restrictions in place there. If anybody could quickly touch on that and just give your views, experience, that'd be really appreciated. Thank you.
I would just add a quick one, if that's okay. Regarding tankers, it depends where the explosive area is. Generally, the first thing you try and do is connect outside the explosive area, but depending on the tanker type, quite often that's quite far away from the jetty. So then you've got an issue with the cable management side of it. But first things first, you try and connect outside the EX zone. There are solutions where you can connect in the EX zone, but you can imagine it's pressurized container. So it's a complicated solution, but it can be done. But obviously, anything like this, you've got to be critical on safety on it. So like I said, the preference is always remove the hazard, do it at the stern if it's out of the EX zone. Some vessels have an EX zone all the way around them, in which case it's not going to be the easiest project to start with.
Thank you. Thank you. Anybody else have anything to add?
Yeah, I completely agree with Chris. It's a challenge. It needs a lot more planning when it comes to tankers. But again, avoiding the sensitive areas is by far the best solution. But again, to answer the first point about the standard, yes, absolutely, it's a global standard. ISO, IEC, IEEE global standard, so it covers all the globe.
Yeah. Okay. Okay. Thank you very much. Thank you. So the other question there is multi-purpose vessel involved in container trade. Will it then have to take shore power like a container vessel? You know, obviously it's slightly different. I did have experience of managing multi-purpose vessels some time back, but they generally, you know, unless they're carrying containerized cargo, they generally, you know, call it bulk carrier berths. So yeah, I just don't know if anybody's got any thoughts, experience, or any knowledge to add to that.
Yeah, I just replied there. If we consider FuelEU maritime specifically, then the regulation in terms of how it incorporates container ships depends on how the vessel's classified from the relevant authorities. So that'll come from the registered certification of the vessel.
The class notation would dictate that.
Yeah, exactly. I put a link there as well. There, frequently asked questions for FuelEU maritime, where it stipulates this as well.
Yeah. Okay. Great. Thank you. Okay. And I think the other question is it's just a good consideration, talking about bulk carriers with low power demand and, you know, ballasting operations, etc., etc. So yeah, I think what Thilo John is getting at there is the power surges on a bulk carrier with some of these large cranes in operation, especially when it's carrying out Gemini operations, for example, and twin crane operations. There's quite a big power demand there. So yeah, that's quite an interesting point there. I think we've just got time for one more question because we're coming up to the end of our allotted time, and we know that the audience has a busy day ahead, and we know that the presenters have a busy day ahead. So I think we've got one more question, and I'm going to say I'm going to look into retrofit cost feasibility. That's the one I'm going to pitch to the audience as the final question, just to finish on. And, you know, it's obviously the $1 million question, if you pardon the pun, but, you know, it really is, you know, how long is the vessel going to be in service for? What are the trading patterns, etc., etc. But do you have any other thoughts to share on this? It's, yeah, like I say, it's not an easy question to answer, but I'm just curious if you have any thoughts on this to share with the audience.
And to say it varies enormously. It really is a case by case. I mean, the first obvious point to make is that with new vessels, ensuring they are shore power is obviously the easiest way forward. To make a ship shore power ready straight from the shipyard is by far the easy solution. But retrofitting, it varies enormously. Sometimes it's extremely easy. Sometimes it's incredibly complicated and probably not worth doing. And everything in between.
But I think, you know, obviously myself, Peter, Maria, you know, we're on here because we've got an interest in the industry. So if anyone is interested in converting vessels or interested in shore power, it doesn't have to be a sales. If anyone's got any queries to follow up with, we're more than happy to answer on this. But like as Peter says, on the vessel side, for retrofitting shore power, etc., we've done an awful lot of the cruise ships, you know, and they've got tight requirements on where the equipment can go. And either it's, as Peter said, it's either a very easy job or it takes a bit of thought, but it can all be done. And it's got to be, you know, but it just takes a bit of thought. And the first thing you can do is examine whether or not it's possible. That's my advice.
Just also to comment on that, yes, as it has been said, it varies enormously from vessel to vessel. I think there's been lots of talk about funding schemes within the shore power sphere, and what I would love to see more of is actually funding schemes for vessel owners for retrofitting, because that is something that I feel would speed up the use and the use of shore power globally. globally. So yeah, we should have more of that if it's allowed to have a wish. But
no, that's it. We can all ask for these things, and somebody might listen to you now that, you know, can impact that, you know. So yeah, all very good points. Okay, I'm going to share the slides now again. The reason for sharing the slides, I just really want to just go to this slide at the end here, and I just really want to, you know, show you that, you know, we've had some very interesting discussions today. We've had some good questions from the audience. We've had some great feedback from all the presenters. You know, and I think we've probably, you know, furthered the discussion a little bit further. So what I'm going to do here is I'm going to share this slide here. You know, I didn't introduce myself at the start. I'm a marine engineer by trade, and then a fleet and technical superintendent managing container vessels. So, and I work in the decarbonisation department, and so does Sarah and Jordan. So please feel free to raise any questions to us internally, should it relate to, you know, the P&I club and how that integrates, or any other technical or operation questions we may be able to help with. So that's the first slide I want to put on. But, you know, more important than this is really, we just want to introduce you to these contacts, which is, you know, Maria, Peter and Chris. And, you know, they've taken their time today to come and talk to you, to share their expertise. We just want to really say to you, and as they've said, that, you know, please feel free to contact them. You know, I think I'm going to allow Chris, Maria, and Peter just to wrap up on this, and just say, you know, how they're comfortable to be contacted about this, and then I'll take the webinar back, and then we'll close it down after that. But I would just like to say thank you to the three of you in particular, and thank you to Jordan and Sarah for your time too. But if you just want to finish off just by saying thank you, that would be really appreciated, and we can go from there, starting with the external panelists. Thank you.
Yeah, well, thank you, Mark. Thank you for the invitation. I guess my final message is just engagement is key. Just, you've got all our contact details out there. You know, it's free to engage with us, to have the conversation, to understand what the challenges are, and have a bit more of a deep dive into each individual circumstance. And we can help, you know, with that. We've all got massive experience in delivering shore power systems, and that's the most important thing in this is the experience. And we can really help you with your individual circumstances.
Thank you. Thank you. Next panelist, please. Maria, I think you're next on the screen there. If you want to go next, please.
Yeah, thank you so much. It's been great to take part in this conversation. Yeah, please feel free to reach out if you have any questions around shore power or retrofit or whatever. We have, as I mentioned, lots of operational experience, and if I were to say some guidance to other ports or vessel owners that are looking into shore power, do not underestimate the operational phase of shore power. Lots of complexity and things to do there. So if you want to tap into some of our experience and knowledge in that area, we'll be more than happy to share.
Thank you. Chris, what's your final words on this, please?
Just to reiterate, thank you so much for allowing us to join the webinar. I think from my point of view, ABB, we pretty much do everything. And, you know, we as a corporation, we invest $1.5 billion a year into R&D. So we need to understand what people are looking to do and where the problems are. Because at the end of the day, we're a supplier, so we need to understand where to focus our attention. So please, any inquiries at all, landside, shipside, energy storage, hydrogen, anything, please don't hesitate to contact me, because we need to know what people are thinking. We may not have a solution for everything, but you know, we need to understand where the pain points are, and we appreciate any input we can get from the industry. So thank you very much again for allowing us to join.
Thank you very much, Chris. Thank you. Sarah, over to you now. Do you have any parting words for the audience, please?
Thanks, Mark. Yeah, just to say, reiterate again, obviously please do reach out as well to us at the club if there's any assistance required, particularly on that contractual side and the drafting of clauses, or if any advice is needed. So you can reach out obviously to myself or to your usual claims handler. And as I say, we've got the decarbonisation expertise team as well, who are there to assist. Thank you.
Last but by no means least, I want to thank Jordan for preparing a lot of the material and, you know, coordinating with the external experts on this and bringing a successful webinar to the table, in my opinion. So thank you for that, Jordan. Do you want to say anything as your parting words from this webinar?
Nothing too much further, just echo what Sarah said in terms of contacting the club for any advice there in regards to shore power. But it's been great to organise this webinar, and thanks very much again to the panellists that have been involved today.
Okay, thank you very much. So I've said thank you to the presenters. I really want to say thank you to the audience. First of all, for coming along, for asking the very interesting questions during the registration process, which we've tried to weave into the webinar. Thank you for the Q&As throughout the webinar. Thank you for your continued interest and support in decarbonisation for the series of webinars which we continue to run at NorthStandard. As I said at the start of the recording, for those of you that missed that, we will aim to combine all the material that includes the slides in a PDF format and the recording within 1 week. That's the target. So please bear with us on that. And then we will pass that on to anybody who is registered for the webinar. Thereafter, it will be shared on YouTube, the video, and obviously all the contact details will be held within that. So I know we're over on time now, so I don't want to take up any more time of anybody in the audience and let everybody get on with their working day. So I just want to say thank you once again and enjoy the rest of your day, everybody. Thank you, take care, and goodbye.